routing and security. And then the third is to enable an entire ecosystem for high-performance virtual networking. As a result, customers can get the benefits and flexibility and cost savings of virtual networking on standard servers, including Power. So I'm available after this presentation today to answer any questions that you have, and thank you for listening to my presentation.
Thanks very much. And last but not least, our friends from Rackspace. And after this presentation, we're going straight into community announcements. Okay. This is going to be a hard question.
Oh, yeah?
Yeah.
Yeah?
From your vantage point as a service provider, what would you say is the most interesting thing you're seeing customers do with OpenPOWER?
So far, our customers aren't quite on OpenPOWER yet, but for us, we're getting really close to having it in the data center, and I think the customers are going to see a lot of value out of like CAPI in particular. I know that's one thing that we're really excited about. I think a lot of people are going to be pretty happy about that.
On a different note, like we haven't had any external customers on the Power Gear, but like we've had some internal customers kind of try it out, for the first time. They're usually on the x86 boxes. They're pretty excited about the openness of it, openness about the firmware, the OpenPOWER firmware. Yeah.
Great. Thanks both. Take it away.
Thank you. Hello, everyone. So my name's Kenneth Wilkie, and I'm here with my colleague, Adi Gangidi. We both work at Rackspace, and our presentation today is we're gonna discuss some of the benefits we've seen of using an open source BMC stack. All right, so just to clarify, I wanted to just define what a BMC is. The acronym itself stands for Baseboard Management Controller, and sometimes people will refer to this as a service processor. It's essentially a small embedded system that lives in your server. It's connected to a variety of sensors. It keeps kind of health checks on the server and provides a lot of out-of-band management functionality. Another important thing it does is it'll log critical server events to let you know if like your RAID battery went bad or if the server is overheating, and it really just helps the people who are operationally running the server make sure that everything's in a healthy working state. For Rackspace, there's three main reasons three main things we would do with the BMC. The first thing we do when our servers first enter the data center, we need some kind of way to turn it on. So the BMC provides the functionality to power on the server remotely. The next thing we're going to try to do is kick the server. A lot of BMCs will provide the functionality to attach remote storage, set up the boot configuration options, and get some of your initial configurations just kind of ironed out. After that point, whenever you're having an issue in production, we don't want to have our data center operations folks, troubleshooting the issues directly. So we'll use the BMC to access like the host console for the machine and go through our debugging process that way. And this slide kind of describes just some of the architecture kind of decisions that are pretty common among BMCs. Like I mentioned before, they're running an embedded system. It's usually an ARM-based processor. On the slide here, we have it that it's often running Linux, but it's usually running some variant of like a real-time operating system that's made by the specific vendor that's building the BMC. A lot of how it does its operations is having direct access to the memory of the host system it's attached in, and some of the I/O subsystems as well. Typically, too, it'll have a dedicated networking interface so that you can attach it to your out-of-bound network. And the overall design is based on an industry standard that's IPMI. It's pretty old. It wasn't designed with the modern data center in consideration, but it describes a lot of the interfaces between the different moving components and gives you some of the networked functionality as well. And so today, the traditional BMC, it's something like the DRAC you would get from Dell or the ILO from HP. These are individually made for each product that you would buy. The security model for IPMI as a protocol is not very secure. The software that runs on the BMC is often going to have some questionable security as well. Usually you're relying on your out-of-band management network being very secure, and that it takes care of most of that for you. Like I mentioned before, the tooling is primarily IPMI based. There's not a lot of libraries for developers to use to interface with IPMI. Usually it results in just using IPMI tool. It's kind of the main option that you have. And there's no easy means of adding your own software to the BMC with most of these products. With some of them, there are some kind of hackery ways that you can go about doing that, but the software is not designed to be modified, and the licensing is often so restrictive that if you do make modifications, you're not able to share these with other parties that could benefit from them as well. And all of this is a lot different when we're talking about an open source BMC stack. And Adi's going to share some of the differences we see in that.
Hey, so Kenneth talked about some of the limitations of using like a traditional closed source BMC. I'm here to talk about how OpenBMC accounts for some of these limitations and what's cool about it. So in other words, in the next 4 minutes or so, I'm going to sell you guys on OpenBMC. So the first great thing with OpenBMC is that you can build your own BMC binary. No one else has to build it for you. This is possible because the OpenBMC source code, it's hosted on GitHub. It's open. The code's very well maintained. And it's extremely easy to build. All you have to do is run those 3 commands on the screen. And it would take about an hour or so to run it on build it on our platform, and there you have the binary that you can just flash it on your server and test it. It's that simple. Also, the fact that the OpenBMC source code, it's on publicly available on GitHub, helps you do security audits for the code that's already existing there. It also lets you look at the incoming commits and see if there's something iffy there, like that'll add some potential vulnerabilities or so. And you can be a part of the review process and kind of suggest them to make some changes to account for those vulnerabilities. Also, with OpenBMC, because you flash the binary you just built, you don't have to worry about whether this binary was digitally signed or not. Also, you know the source code that you just built this binary against. So you feel secure, basically, knowing what's going on in your data center. OpenBMC has modern tooling. This compared to IPMI, like Kenneth mentioned, it was developed in 1998, and it was developed for 8-bit microcontrollers in mind. So it's pretty ancient. It wasn't built for the modern day data center. Keeping in mind the scalability or complexity. OpenBMC accounts for this by making some modern design choices. So you have a REST-like API where you can do some calls, targeted calls to get the exact information you need. You don't have to run this very generic IPMI tool binary and then just parse all the data. You get basically what you're expecting. Also, with OpenBMC, you can SSH into the BMC and access the host console. You can see what's happening in the host. You don't need, again, a specific tool to do that, but you can build one if you want to, if you're kind of used to that sort of a flow. Also, this is the greatest thing. This is the greatest thing, according to me, about OpenBMC, that it kind of runs the latest stable Linux kernel, and they're constantly moving to a newer kernel. Right now, I think they're working to move to a 4.4 kernel. This is great because it brings in security fixes that are upstream. It gets updated drivers. It gets new kernel functions. So you don't have to write some of these functions yourself. You can leverage that other people have written. With OpenBMC, you can customize it. That's, you can add or remove services that you want or don't want, or you can change them before you build it. Some of the examples examples of things that you can do, in terms of customization is, say, for example, you don't like the authentication model that OpenBMC follows, or say you think like the REST API structure is a little iffy, you want to change it, or if you are trying to integrate your app with OpenBMC and feel like it can be changed a little bit so that it gets a better fit. So you can do all of these with OpenBMC because the source code is open. Some of the significance of this is basically that integration with Ironic and OpenStack becomes much easier. There's also an SDK available to build Linux applications for OpenBMC, so you don't need the hardware or server running it to build and test your application. You can use that. I'm kind of running a little late, so I'm going to sum it up quick. So with OpenBMC, another cool thing is you can contribute. You can basically change the way server management is done tomorrow. There's a lot of transparency in the community, and there's GitHub, there's IRC, and mailing list that you can start with. So I'm going to summarize this talk by talking about how OpenBMC has changed the BMC model at Rackspace. But this is not specific. This story is not specific to Rackspace. This could be you. This could be your company, your organization. Traditionally, what we used to do was, if we have an update or a fix that we want to do on the BMC, we would talk to the ODMs. And then the ODMs would talk to the BMC OS suppliers. And they would make some changes to the source code, build a binary, and then give it to us. And then we would flash it on our, in our lab to test it first, then put it in the data center. So this is a huge flow. There's a lot of communication, and communication is error-prone. So with OpenBMC, this is different. We just, if this change is small enough and we want to do it in this OpenBMC source code, we just go ahead and do it. And our ODMs are aware of all of this because all the activity is happening publicly. We also get to use everyone else who is contributing to the OpenBMC source. So at Rackspace, we're really, really excited about OpenBMC. I hope so are you. Thank you.
Hey, thanks, guys. I'm going to start our community announcements now, as the mics are being removed. If I could get John to come up on stage, give us a few words. John Zanos, for those of you who don't know, is the chairman of the OpenPOWER Foundation, and John has graciously agreed to talk to us and say a couple words today. So I'm going to turn it over to John. And then right after John, we have a couple of community announcements that we'd like to get out there that'll be of particular interest to the developer community. Pretty exciting stuff. I'm just going to give you the handheld. And no tough questions.
Okay. Thanks, Randall. And thanks, everybody, for coming. It's not so gracious. This is a community I worry and care most about, the ISV university, the people that are working use cases. And thanks for a group of excellent presentations. From the IBM side, a lot of real deep engineering and use case work. From Tenjin, the excellent work on a real kind of important use case. Redis Labs, Jeff, love the TCO analysis. We got to get to that sort of analysis. How do we simplify? How do we create business value? How do we actually represent it in a financial and technical way? Kelly, thank you so much. NFV is an excellent use case for power, for the community in general, and most importantly, for the telecom marketplace. Antonio, simplifying, making things easy is so important. Who am I missing? The Rackspace team. Do they already lead the world-famous developers? I appreciate you guys coming. I mean, I think what you're doing is another important example how you use the technology, but more importantly, how you kind of use it in a real-world use case and how you're trying to simplify its deployment. That's the stuff that matters. Andrew, Adriana, thank you for pointing out that developers like things fast and easy, and like many of us simply are at our core somewhat lazy, but it's because we want code to be developed quickly, we want to solve problems quickly, we want to get it in the hands of end users quickly. We're going to, next year, and every time we do this, we're going to really focus on building this community and the university community, because that's the community that talks about problems, solving them, and putting them in technical and financial terms and operational terms. It was great to see so many people using some of the tooling we've created as a company within Canonical to make that deployment easy, because that's what's going to make adoption easy. I'll add just a couple thoughts and give it back to Randall. The importance of talking about use cases is ultimately what drives adoption, be it NFV, deep learning. Oh, the SkyMind team as well, an excellent example of how to use deep learning with power to accelerate the value of that proposition. Big data, as we talked about, databases, these are real use cases that matter. We'll continue to focus on this. All these presentations will be available. They've been taped and videotaped and be available on our website. We're going to be pushing it out to all the community members, all the press that has been here over the last couple of days, and all the analysts. Thank you. So long 2 days, but thank you so much for taking your time. Excellent presentations.
Thanks very much. A big round of applause for John. Okay, if I could bring Sam on stage briefly. For those who don't know Sam, Sam is the one that creates a lot of buzz and noise about OpenPOWER Foundation. My handle's BuzzGen, but I think Sam might take that title. He's certainly generating more buzz these days. Take it away, Sam. Just talk to us about the programs you've got going on.
Awesome. Thank you, Randall. So yeah, as Randall said, I kind of do lots of the social and digital media for the OpenPOWER Foundation. So everything that you see on our blog, our social platforms, usually it goes through me. And so I'd like to extend an invitation to anybody in the room to please stay in touch. You know, I heard a lot of great use cases, as John just pointed out. I would love to talk about you guys on our platforms, so please reach out. OpenPOWER Foundation is a available voice for our members to use to talk about the work they're doing for OpenPOWER. So yeah, I'm just going to go through a few things here about what some activities we have going on, designed to enable developers, to get more involved with OpenPOWER. The first here is the OpenPOWER Developer Resources Map, which is now live at developers.openpowerfoundation.org. It shows where we have either clouds or client centers or research centers all across the world. And developers can use it. You can see across the top there are 4 filterable categories that allow you to sort of select the criteria that sort of align with the project that you're working on. So if you want something free that uses FPGAs, you can input that in the filters up there, and it will narrow down the sites. SuperVessel will probably be the one that you go to. If you're working on something where you want to scale and you need a lot of cores, you can use filter the fee-based sites, which are more premium resources, and it'll give you something like OVH or Stack Velocity for you to try out. So this is something really great that we're hoping a lot of people are going to be using. And right now we have 19 locations on there, but we're continually adding some. Looking to have 40 on there by the end of the year. So developers.openpowerfoundation.org. Check it out. So here we have the OpenPOWER Developer Challenge, which Brad talked about it in his keynote yesterday here. Rob High talked about it in his keynote yesterday as well, and I'm talking about it again. Not quite the clout of those guys, but it's something I'm very excited about. So it's open now. You can register to participate at openpower.devpost.com. We're giving away close to $17,000 worth of prizes, including an all-expense paid trip to Supercomputing 2016 for the grand prize winner to kind of showcase the work that they did as part of this challenge in front of their peers. And also unofficial prize, but Brad McCready is going to take the winner out to dinner as well in Salt Lake City for Supercomputing. So there's two ways that you can participate. The first one is the open road test, and this is one where you can really kind of showcase, your creativity and what you're doing by porting and optimizing a new application for OpenPOWER, and then using accelerators to, really crank up the performance and go faster. The second way that you can participate is the Spark Rally. And in this one, you'll be training an accelerated deep neural network with GPUs or other accelerators to recognize images through ImageNet with greater accuracy. And then, tell us about how you plan to scale it up with Spark. So all of these are going to be run through SuperVessel, which I mentioned earlier is our open development cloud. You can sign up for it through our website, but again, registration is open as of today. The official submission period begins on May 1st, so we're giving you guys some time to start to form teams, think about the potential projects that you'd like to do, and also get a head start in registering for SuperVessel and playing around in the virtual environment. And then the submission period ends August 2nd, so roughly 90 days, 3 months to finish your entries. And finally, this is one that we're also very excited about. It's the OpenPOWER Application Ecosystem Initiative, which is a mouthful, I know. But the goal here is to port open source codes over to OpenPOWER. If any of you are familiar with Bounty Source, we have a page through them where the University of Michigan, who is administering this program for us, is going to be posting codes up on our Bounty Source page, and then depending on the difficulty of code, the average payout, for a successful port is going to be a $100 bounty. But as some are more difficult, it'll be more. As some are less difficult, it'll be less. But there's going to be a whole range of them for really kind of any level of developer who's interested in participating. This is actually, it needs to be updated, but it is open to everybody, but we are sort of, a little bit geared towards students and universities because students need beer money, and this is a fun and easy way for them to do it. So just to recap our 3 events, the OpenPOWER Developer Resources Map, developers.openpowerfoundation.org, the OpenPOWER Developer Challenge, openpower.devpost.com, and the OpenPOWER HPC Application Ecosystem Initiative available at Bounty Source. Just search IBM HPC. Thank you very much.
Thank you. Thank you, Sam. And last but not least, Lance Albertson from Oregon State University. Did I pronounce Oregon right? Excellent. I've been taking flack for that. Okay, Lance, tell us what you got going on in Oregon. And I think there's an announced slide for Lance as well.
Yeah, I'm Lance Albertson. I'm director at the Open Source Lab at Oregon State University. And let's see here. I'm just going to do a quick one slide on what we've been doing. We primarily host a lot of open source projects from around the world, a lot of medium to large open source projects. So we're the home for the Linux Foundation, the Apache Software Foundation, and a lot of other projects. And so we've also had a long-term relationship with IBM, enabling those projects access to the Power architecture. A couple years ago, we strengthened that relationship and actually got access to OpenPOWER machines before they were actually Power 8. And started creating a cluster, an OpenStack cluster for these projects. So right now, we currently have 3 nodes that are running as a compute node using all open source software, OpenStack. And I've worked with a lot of the IBM engineers to make it work, basically porting a lot of what Power KVM was. And we've been really enabling a lot of the open source projects. So currently we have about 24 projects. Some of them are universities. We help projects such as the Go language to be ported to the Power PC Little Endian architecture. A lot of other projects are on there. A lot of the problems we were running into, we actually were bringing those projects on board to fix some of those problems. It was really great. We have about 60 virtual machines running on there. We're in the midst of trying to revamp the whole infrastructure to make it a lot better. We're basically a much smaller version of what SuperVessel is, and we're mostly dedicated towards the open source software projects and so forth. If you're an open source project and you want to have access to this cluster, I have a link there down at the bottom. We're working on revamping the cluster. We just upgraded the memory thanks to IBM, so we have a lot of memory now on those machines. And I'm working on upgrading to the latest stable OpenStack release, Liberty, and upgrading the networking backend so that the projects have a lot more flexibility in what they want to do. And then hopefully eventually we're going to be working with Mellanox on some switching gear connected to that and allowing the cluster to grow as well. So I want to thank IBM for donating and supporting the infrastructure. And if you have any questions, I'll be around. Thanks.
Good job. Thanks, Lance. I'd like to invite the speakers on stage. We're over time, so we're not going to do a formal Q&A, but if anyone wants to hang back, I'm sure some of the speakers can hang back for a few minutes. I do have some Ubuntu goodies. If any of you are into Ubuntu and want to come up and talk, I'll gladly share those. So could the speakers just come on up and maybe we do a little group video shot just to wave goodbye or something. And thank you for everyone who stayed through this whole session. We had a lot of content and a lot of stuff to go through, so I really appreciate your time and attention. And my address is up there. Please send me lots and lots of email. I love email. And I'm happy to connect you to anyone in the community who you think might be useful. And yeah, but don't be shy. Reach out. So here's maybe we should come. It's kind of like the hardware reveal, right? Remember yesterday we had more than 50 systems? Well, this is the wetware reveal. All right, humans. Come on in, everybody. Okay, we're all up on stage. So, oh, Lance, come on up. Sam, John, if you want. Anyone else? No. Oh, you're going to take a picture, okay. Person in the hall who's ignoring us, come on up. No. Do we got enough room at the end? I don't want anyone behind the pedestal, so let's come on down a bit more. Here we go. Okay. So on 3, we're all going to wave to the crowd, the massive crowd that's out here. Look, 500 people. Okay. 1, 2, 3. Wave and smile. Thanks for coming, everyone. Have a great 2016, and more power to OpenPOWER. Take care.